Regioselectivity. Regioselectivity tells us where the reaction will happen when the reaction in a molecule can happen in more than one position. Let's look at the case of E2 reactions. So when we have an E2 reaction, the E2 reaction will happen faster in a more substituted alkyl halide. The reason for that is because the more substituted the alkyl halide will result in a more substituted double bond, and the more substituted double bond is more stable. So let's look at these two reactions below. We have, in both cases, we're going to end up with an alkene, so they are both eliminations. And let's see which one of these two alkyl halides will react faster. In the top one, we have a primary alkyl halide. So that carbon, you see right there, is connected only to one R, then it has the halogen, and then it has two H's. That's why it's a primary alkyl halide. What will happen is the alkoxide, my base, will come, get the proton, the electrons will go to form the double bond, and the Br group will leave. So, and this is the alkene that I will get. You see this alkene, it's connected to 1H, 2H, and 3H. So that is a primary, a monosubstituted alkene, So because it's a monosubstituted is going to be less stable than an alkene that is more substituted. Now, if we look at this tertiary alkyl halide, that carbon right there, it's connected to 1, 2, 3 R's. So when the base, the alkoxide, comes, gets the hydrogen, it collapses to form the double bond, then the Br will leave, right? So that will result in an alkene that looks like this one. So you see this alkene has 1H and 2H. So this one is di-substituted. So the more if I start with an alkyl halide that is tertiary, I will end up with a more stable alkene because it's more substituted. When I start with a primary alkyl halide, I will finish with a monosubstituted alkene, and that's less stable. Monosubstituted. There we go. And so that has a name in chemistry, and that's called the Zaitsev rule. So when alkyl halides can give you two different products, the favored one is the major product will be the one that is more substituted. So let's look at this example. So here is a beta elimination that is happening when you have two or more different beta carbons. So what it means is that this one right here is my alpha carbons, but then I have three types of beta. I have 1, 2, and 3. And so here we have the two red ones that will form product A, and I have the blue one that will form product B. You can pause the video here and try to figure out how you would get one and the other, and I'll give you the mechanism in just a minute. So because I have my leaving group here, imagine I have that H available, so my alkoxide could come, then that will collapse and that will leave. So that will give me product A. Look, product A is the same if I have the double bond here, if I have the double bond there. So if I have my hydrogen hanging from the beta, the base, so I have an alkoxide here, can come, and then that will collapse, and that will form the double bond in that position, so that will give me the double bond right there. And so this is how you can get both of them, depending if you use the red betas or the blue betas. And what the Zaitsev rule says is that the major product, the more stable one, is the one that is going to be favored. So here we have another example, and in this example, in this slide, what I'm showing you is that a reaction, we can say that a reaction is regioselective when it favors only one of the products. So it yields, that's what it means by yielding predominantly. So this is what it means by we majorly get one of the products. Okay, so let's look at the mechanism here again. So if I get one of the hydrogens that it's in the blue, I will form a double bond right here. So that will give me the major product. And if I get one of the hydrogens that's coming out from here, that will give me the less stable alkene, which is the one that will form right there. So you can practice, you here have the transition state for each one, so you can see how the bonds are forming. So these two are forming, these two are breaking. So this is another example for you to see how you can form the sides of product, which will be the more substituted, in this case is tri-substituted, or the less substituted one, which is the minor product.